Okay, hello everyone. Welcome to the Programming Languages class. I am Dan Grossman, and I'm looking forward to having a great class with all of you. And what I want to do, as sort of natural in this sort of first lecture, is just give you an overview of what the class is going to sort of be like and get you excited about what we're going to do. And basically over the next 10 weeks, I hope that we will together learn the fundamental concepts underneath programming languages. So I don't intend for this to be an easy course, but I think it's something that with hard work and patience and coming in with an open mind ready to learn new things, it has the opportunity to make everyone a better programmer than they came in before the course. And in fact, I think it'll make you a better programmer in programming languages we're not going to study at all, and even in programming languages you already know. So the idea is that we're going to learn the concepts that come up in any programming language and get better at recognizing them despite the surface level differences between different languages. So what tends to happen all the time when people look at a course like this is they say, oh, that's the course that teaches ML, Racket, and Ruby, which are the three programming languages we're going to use. But I really don't like that description of the course. Because the idea is that we're just going to use those languages as vehicles to learn the concepts that come up in any programming language. In any case, this video is not going to cover programming languages at all. It's going to be more the course mechanics, that sort of stuff. Then the next one will do a little bit more of course introduction that's programming language specific, and then we'll get going into the course content. Here's a real simple list of things you can do right now, even before you get started on the first homework and things like that. The obvious thing to do is get familiar with the course website, how the different pieces are laid out. If you have taken a Coursera course before, I think it'll be fairly familiar, but we all do things a little bit differently. And if not, I don't think you'll have too much trouble. But take a few minutes, look at the different sections, get started on the discussion board, that sort of thing. Second, I hope you'll complete the beginning of course survey. I think that'll be fun so that we can all find out more about the community that we're all participating in, and shouldn't take you any time. And third, and this is probably the most time-consuming and important, get the software installed that you need for the first homework. We're going to be using an editor and a programming language and a couple of tools that you may not be familiar with. And it's a bit of a pain to get it all installed. We've provided step-by-step instructions that you can just read through. We've also provided some videos of me literally installing the same software on Windows, which may be helpful. And this is just stuff you may as well do now, that if you wait until you're ready to start the homework, you'll just find it more aggravating. So it's a good thing to do early, maybe after even just watching this first video or the second one or something like that. Give you a brief overview of the sort of materials that will be available to you as you go through the course. Obviously, there'll be lectures like this. I also have written reading notes covering all the same material. So you don't need to read these because they'll by and large cover the same material that we cover here interactively with slides and writing code and with me talking. But they can be really helpful if you want a more precise explanation or you just like to read a few sentences to get exactly the point I'm trying to make. And so I really encourage you to read those, and we'll always post those together with the other lecture materials. Any code that I show or write or we go through in one of the lectures, I'll post separately so that you can actually have the text file rather than having to retype it or paste it out of a PowerPoint slide. We'll have homework assignments. Those homework assignments are going to get graded both by scripts we've written that are going to read through and run them against tests and give you points and that sort of thing. And we're also going to use some very simple peer assessment, meaning that you're going to have your assignment graded by a few other students in the class, and you're going to grade a few. This is going to be very simple. It's going to be something like a rate on a 1 through 5 sort of thing. And this helps me emphasize that it's not enough to just pass the tests. What we're trying to do is learn how to write software in clean, elegant, beautiful ways. And that's something that humans can evaluate much better than computers. We'll also have a couple exams, one about halfway through and one at the end. And that's because there's a number of concepts in this course that I want you guys to learn and answer questions about that you can't really demonstrate your knowledge of by just writing programs. So most of the homeworks will pretty much be all programming, and then the exams will ask some other more conceptual questions. In terms of the homework, we'll probably have 7, so there won't be one for every week of the course, and I'll keep you apprised of how that's working out. You should do them individually, although of course you'll get help on the discussion board and from fellow students as you need. And the thing I always like to emphasize is if you want to do them efficiently and learn the most from them, the counterproductive way to do it is just try to get the right answer and crank out the code as quickly as you can and turn it in. Usually you'll actually find it takes less time if when you approach a homework question, you look at, hey, what concept is this question related to that we went through in the lectures? Then write the code that pretty much has it working, and then to make sure you got it, test your code, and even try some variations. Say, well, I think this is right, but if I change this around a little bit, I bet it's wrong, and here's the test that's going to fail. And I think if you do that, you'll get a lot more out of the homework, and you'll be much more confident that you have the right solutions. Just as one more logistical or structural thing, sometimes on the homeworks I'll have what I call challenge problems. Those are just somewhat more difficult problems that those of you who find the course a little bit easier might enjoy doing and that you can learn a lot more from. But for the rest of you, you don't have to do them. We'll make them worth just a small number of points so that people who do them feel they get something tangible out of it, but you are welcome to skip them, so you can think of them as optional. Last sort of thing about the homeworks, I've sort of learned from experience that students are sometimes surprised at how precisely and concisely my homework questions are worded. I think that's because I'm a computer scientist and I tend to write English the way I write code, which is I put exactly what needs to be there and make sure it's defined very precisely. And I think for technical questions like a homework problem, that's the great way to do it. But what this means is that if you're used to sort of standard internet work where you just skim things and try to get the high-level idea, you might find them very frustrating. So I encourage you, when you get into especially the first homework assignment, really try to trust that each word and phrase there and each question is there for a reason. Read it all the way through. I've tried to keep them as short as possible, just a couple pages long usually, and I think you'll find them a lot easier to approach if you take a sort of no skimming allowed view. Now that doesn't mean that the homework will always be crystal clear to you. So if you are confused, that's what the discussion board is for. I may have even made a mistake, although I certainly don't intend to. And what typically happens is you think a homework question is very confusing in how it's worded, but then after you do it, if you go back and read the question again, you'll see, oh, that's not confusing at all. Maybe I was the one that was confused. And that's how you learn the material. And I'm looking forward to exploring that process with all of you. A few other things we'll do in the class. I'll try to put on the webpage everything you need, but when you're learning new programming languages, learning new ideas, you sometimes have to look up details elsewhere. I won't do that on purpose, but you also shouldn't be surprised if you find yourself looking up some language feature that's not covered in the lecture or something. I hope to arrange Google Hangouts with a few of you and let the rest of you watch. More details on that to be determined as we figure out the times that'll work best for me and for some of you. And occasionally I'll have some optional material, some offshoots where I'll say, here's a little video that if you know, say, C programming, you might appreciate this connection to something you already know. There's a small group of TAs that are mostly behind the scenes, but we'll see how the course goes, and maybe they'll do some video question answering or something so that they can have some of the fun too. And the bottom line is I just hope this is a great adventure for all of us. I hope to really create an active, energetic community. I hope to share with you my passion and my excitement for programming languages. This is my favorite class in the world, which is maybe not too surprising that that's the one I chose to create for this Coursera environment. And I actually have a now not-so-secret goal, which is it's well known for these classes that only a small percentage of students who start the course stick with it all the way through and finish it. And I hope we set records for that. I'm not going to make the class easy. I hope it's challenging, because that's what I think will actually keep you engaged. But I would really love for people to look at this community we're creating 10 weeks from now and say, wow, that was one of the best ones. How did they do it? I hope more courses are like that. And let's see if we can work together to make that happen. Okay, so at this point, you are welcome to stop watching this video. I've covered what I need to cover for the course. But I thought if you're going to spend all these hours over the next couple months listening to me, you might like to know a little bit more about me, just like I would be very curious to learn a little bit more about you, at least from filling out the online survey so I can get some aggregate information. So this is just for fun if you're curious. This is my country. This is the United States. I grew up right in the middle of it. Until I was 18 years old, I lived in the suburbs of St. Louis, Missouri. After that, I went off to college in Houston, Texas. I loved going to Rice University. I really missed the burritos. That's probably my favorite thing about living in Texas. After that, I went and got a PhD at Cornell University in Ithaca, New York. It's a small town. If you're not familiar with New York State, that's a 4.5-hour drive from New York City. So it's actually a small town, quite a distance from the larger cities. And then in 2003, I moved to Seattle, which is my favorite place that I've ever lived in. And I've been a faculty member at the University of Washington since then. A little bit about my research and teaching and what I do. I do consider myself a programming languages person, but a bit of an applied one, or a little bit of a strange one, where what I like to do is take the fundamental beauty of programming languages, things like the functional languages and type systems that we're actually going to study in this course, and instead of necessarily working to make them better, I try to take the ideas behind them and apply them to other areas where you might not expect them to be as applicable. So I've worked a lot over the last few years in trying to make multi-threaded programming easier so that you can more effectively and efficiently program the multi-core chips that are becoming ubiquitous in the computing industry. I'm now working a bit on how you can better write software that's more energy efficient, so batteries last longer and you spend less money on your power bill. I've worked on other things a bit, like web programming or dealing with programs that process massive amounts of data. And this is really just like the way I like to operate, that I like to collaborate with others that maybe don't have as much of a programming languages background, and then I learn from them some of the real-world needs that they have, and somehow we combine to make progress and to make computing and software better. Outside of that, I don't spend all my time sitting inside recording videos and doing research. I love to go hiking. This is a picture of me from up in Montana last summer. About once a week, I go and play ice hockey. You can't tell this is me at all, but that actually is me under the gear there in the front of the picture. I love riding my bike. This is me finishing up a 200-mile or 320-kilometer bike ride from Seattle to Portland a couple summers ago. And if that's not enough sort of cute, fun pictures, this is the dog I live with. And her name is Red Dog, and she's amazingly awesome. Okay, I also like to travel. Here's a list of countries I've visited, ranked in order from smallest to largest. So I'll be curious to see if we have students in the class from most or possibly even all of these countries. I've also traveled all over the United States. I'm missing 3 states. I'm still hoping to get to Alaska, Delaware, and Hawaii. So welcome. That's a little bit about me. Remember to tell me a little bit about you. And in the next video, we'll get started on programming languages.